The word energy is used a lot, but it is rarely defined in an intuitive manner. We often think of energy as a mysterious, invisible substance that flows from one object to another and makes things happen. But what is energy exactly? That's what I'm going to show in this video. To understand what energy is at a fundamental level, we first have to understand what it means for something to have energy. When something has energy, it is in a state of imbalance. This means it is going to experience change, which can manifest as movement, heat, light, etc. This change will continue until an equilibrium is reached, at which point no further change is possible. We can thus define energy as a state of imbalance. But if energy is just imbalance, what exactly is being transferred when energy is transferred from one object to another? The surprising answer is that nothing is actually being transferred. What is actually happening then? The best way to answer this question is with a visual simulation. Here we have a row of marbles that are connected to each other with springs and can move horizontally. The marbles are in equilibrium when they are all evenly spaced out and with zero velocity. What happens when the marbles are in equilibrium? You guessed it, nothing. The simulation is running, but nothing happens, and nothing is going to happen regardless of how long we leave it running. In fact, you cannot even tell that the simulation is running. Now let's move the first marble slightly to the right. What do you think is going to happen? The first marble is now imbalanced since it is closer to the second marble than the left boundary. The second marble is also in a state of imbalance because the marble on its left is closer to it than the marble on its right. Remember that energy is a state of imbalance. This means the first two marbles have energy. The remaining marbles are in equilibrium and thus don't have energy. Both the first and second marbles will experience change in order to return to a state of equilibrium. The first marble will lose its velocity, while the second marble will move to the point that is exactly in the middle between the first and third marbles. What happens next? Notice that the third marble is now imbalanced because the second marble is closer to it than the fourth marble. In fact, the third marble is the most imbalanced and thus has the most energy out of all the marbles. You can start to see a pattern forming. The imbalance, and hence energy, appears to be moving to the right one marble at a time. It is, in fact, this imbalance, not some invisible substance, that is moving when energy is transferred from one object to another. So now we can deduce that the imbalance will move to the right until it reaches the rightmost marble. What happens next? The boundary can't move, which means the rightmost marble will remain the most imbalanced marble and hence with the most energy. The only way it can reach equilibrium is if the imbalance shifts to the marble before it, that is, if the energy starts moving to the left. That is precisely what happens. The imbalance is reflected off the right boundary and starts moving back towards the leftmost marble. This demonstrates that energy cannot be destroyed. The only way an imbalanced marble can reach equilibrium is by shifting the imbalance to the marbles next to it. Similarly, the only way a marble can become imbalanced is when the marbles next to it are imbalanced. This means energy cannot be created either. In fact, the marbles in this simulation will never reach equilibrium. The energy will keep reflecting between the left and right boundaries. Regardless of how long we leave the simulation running, we will never observe a state where all the marbles are equally spaced out from each other and with zero velocity. The total energy neither increases nor decreases, but it spreads out over more marbles in a process known as increasing entropy, which is the topic for the next video. To conclude, let's summarize what we've learned from this video. Energy is fundamentally a state of imbalance. An object that has energy will experience change in order to return to equilibrium. In doing so, it will cause other objects around it to become imbalanced, thus transferring its imbalance, that is its energy, to them. Hopefully, this gives you a more intuitive understanding of what energy is at a fundamental level.